This is Mrs. Appia with Grade 8, Lesson 6, Dilations on the Coordinate Plane. In this lesson, students learn the multiplicative effect of scale factor on a point. Note that this effect holds when the center of dilation is the origin. In this lesson, the center of any dilation used will always be assumed to be 0, 0, the origin. This is our last lesson before the mid-module assessment. Pause the video and copy the essential question, how do you find the coordinates of dilated points from the center origin, given the original coordinates and the scale factor? In the example 1a, let's just take an informal look and see if we can figure out what is happening with the coordinates. This is a dilation from center OO by a scale factor of 2. And the original coordinates of the point A are 3, 2. The dilated point has coordinates 6, 4. So take a look and compare the two sets of coordinates. Keep in mind what the scale factor is. Hopefully you'll notice that the x coordinate has doubled and the y coordinate has also doubled. And the scale factor is 2. Now, test your assumption and see what you would expect in example 1b. In example 1b, we are representing a dilation, again from center OO, and this time with a scale factor of 4. So how might you expect your coordinates from A to A prime to change? Well, let's take a look at the coordinates for A. The coordinates for A are 3, 3. Just based on the previous example, what would you expect the coordinates for A prime to be? Now check and see if they are. Look along the x-axis and the y-axis, and you'll see that they were 12. Did that meet your expectations? Turn the page. In example 1c, first, let's review what we learned in Lesson 5. Remember that we found the location of dilated points using our knowledge of dilation and scale factor. In other words, we were given a point, for example 5, 2, right here, point A, and we were told that the scale factor was r equals 2. Remember that the center of dilation is the 0, 0, the origin. We created the following picture and determined the location of A prime to be 10, 4. So what we did is we took a look at we dropped this down, we dropped the point down to see what the vertical distance was, and we found that to be 2. And then we took a look at the segment OB. And we know that the segment OB has a length of 5, and we know that the scale factor is 2. And we use that to find the length of OB prime. Using the definition of dilation, OB prime, the dilated point, is equal to the scale factor times the length of the original segment OB. So we found the length of OB prime to be 10. And that means that our x-coordinate is 10, which it is. Then we took a look at A, and we dropped it down and we saw that that is 2. So we are looking for the length of this segment, which is, let's call that OA prime. Actually, that would be the 10 here. Let's go back and remember we're talking about this distance now, and that distance is 2. So our original segment is 2, and we want to find the length of the dilated segment right here. So we have AB is the original segment. The scale factor is 2. And we're finding the length of the dilated segment, which we'll call A prime B prime. The length of the original segment is 2, And we find that by just counting down to the distance to the x-axis. And that is the length of the dilated segment AB prime. And that gives us a length of 4. So A prime B prime is equal to 4. And so the distance going up, which would be our y coordinate, is 4. How can we determine the coordinates of the dilated point? In other words, is there a shortcut? Well, notice the horizontal distance from the x-axis to point A was multiplied by a scale factor of 2. That's to say that the x-coordinate is multiplied by the scale factor of 2. Similarly, the vertical distance from the x-axis was multiplied by a scale factor of 2 as well. So this distance was 5, and we multiply it by a scale factor of 2. So based on what we know about dilated segments, when the center of dilation is around the origin, the coordinates of the dilated points are found by multiplying each coordinate by r. So when it says, how can we determine the coordinates of the dilated points? Remember, this occurs when the center of dilation is 0, 0, or the origin. The coordinates of the dilated point are found by multiplying each coordinate by the scale factor. In example 2, in lesson 5 we were given the point A is the coordinate 7, 6 and asked to find the location of the dilated point A prime when the scale factor is 11/7. Our work on this problem led us to the coordinates of approximately 11 and 9.4 for point A prime. Verify that we would get the same result if we multiply each of the coordinates by point A by the scale factor. Okay, so what we looked at in that problem, we had our origin of 0, 0, and we had this distance of 7 and this distance of 6, and that was called A. Now let's just draw a ray through that. And then we had A prime, and we had a distance. This distance is 11, and this distance is 9.4. So what we want to do is we want to verify that our method that we just wrote down here works on a example that we've already dilated and found the coordinates. So we've got A prime is equal to the original coordinate times the scale factor and the original coordinate times the scale factor. So our original point was 7 and the y-coordinate was 6, and our scale factor is 11/7. So if we multiply 7 times 11/7, that equals 11 for our x-coordinate. And if we multiply 6 times 11/7, let's see, we have 6 times 11 over 7. 6 times 11 is 66, divided by 7, and that's 9 with 3 left over, which is approximately 9.4. That's great. So we've got 9.4 for A prime. So this is just verifying that this method does work. In our next example, we want to know what's going to happen if our coordinates aren't positive. Based on what we've learned so far, given the point A is equal to negative 2, 3, predict the location of A prime when A is dilated from a center at the origin, OO, by a scale factor of 3. As before, mark a point B on the x-axis, then OB prime is equal to 3 times the length of OB. And where is OB located? Right, so what we're doing now is we're taking a look at what happens when your coordinates are negative, or one of them might be negative. Okay, so the first thing that we want to do is to drop A. And we see that this has a distance of 2. And so we have 2 times the scale factor, and that gives 2 times 3 is equal to 6. So our second step then, or rather this was our first step, was to just drop the line. Our second step is to see what our new x coordinate is. That's what we figured out here. Then our third step is to draw the point. And again, this is reviewing what we learned in lesson 5. So we go over here to point 6 and we draw our point. Then step number 4 is to draw the parallel line, and I'm going to write that up here. Step 4. Draw the parallel line to AB from 6. So I already know my new x coordinate is 6. Let's move that down a little bit there. I already know my new x coordinate is 6, and I want to find out what my y coordinate is. Then our, let's see, we're on step 5 now. Step 5, our coordinate for y is 9. This distance, we had 1, 2, 3 going down, and so this would be 3 times as long because it has the same scale factor. So our distance A here was 3, and it has the same scale factor, so 3 times 3 gives us 9. Notice that we haven't worried about a negative sign. Right now we were just using the distance to find the point. So we wanted to find the location of the new point, and that is B prime is at 6, 9, and it is a negative 6. And that was using the method that we learned in lesson 5. So now we think, well, what about the negative number? Well, notice that our coordinate for A was negative 2, 3. That was the old coordinate. And using our new information of multiplying by the scale factor, we have negative 2 times the scale factor for the first coordinate and 3 times the scale factor for our second coordinate. So negative 2 times our scale factor of 3, and sorry, I stand corrected here. This, our y coordinate, oh, I guess I was right. I got confused with the scale factor being the same number. Alright, so then we have 3 times the scale factor. So again, this is our scale factor that we're multiplying by, the original points. And that gives us the negative 6 and the 9 for B prime. Okay. We're going to skip down to number 2 next. And the problem says, point B, which is negative 8, 5, is dilated from the origin by a scale factor of 1/2. What are the coordinates of point B prime? So our original point B is equal to the coordinates negative 8, 5. And we've learned that you take the original point and you multiply it by the scale factor, and the original coordinate and multiply it by the scale factor. And here our scale factor is 1/2. So B prime is equal to negative 8 times 1/2 and 5 times 1/2. So you're multiplying each coordinate by the scale factor. So our coordinates for B prime are negative 4, and 5 times half is 2.5. And one of the things that I want you to notice here is that when your scale factor is less than 1, remember that it pulls the dilated point toward the origin. So the point was at negative 8, 5. Now it's at negative 4, 2.5, which would be closer to the origin. And then in this example, we had a whole number scale factor, and it pushed the dilated point away from the origin. So just keep that in mind. We're going to skip a couple of problems. We'll do those in class. And we're going to go ahead to example 4 next. In example 4, it says, what is the multiplicative relationship between a point and its dilation? So, what we've learned, if we have a point, let's call it P1, P2. So these are the coordinates of the point. If that point is dilated from the origin, and remember all of this applies to when it's dilated from the origin, using scale factor equals R, then the dilated point P prime is equal to R times the first coordinate P1 and R times the second coordinate P2. So that's just formalizing what the multiplicative relationship is between the point and its dilated location. We're going to take a look at a two-dimensional shape now. We're going to take a look at triangle ABC. And triangle ABC has coordinates for point A, coordinates for point B, and coordinates for point C. Please include this in your notes. Our coordinates for A are 2, 3. Our coordinates for B are negative 3, 4. And our coordinates for C are 5, 7. And we are going to dilate triangle ABC from center OO, the origin, using R equals 4. Find coordinates of triangle A prime, B prime, C prime. Do you feel like you could do that on your own? If you do, go ahead and pause the video and do it on your own. Okay, so we have our original point for A, and we'll have to do this for each one. We have A prime is going to equal the first coordinate times the scale factor, 4, and the second coordinate times the scale factor of 4. And our coordinates are 2, 3. So our coordinates for A prime are 8, 12. For point B, B prime will equal the original point times the scale factor, 4, and the original coordinate 4 times the scale factor of 4. So again, what I want you to notice is that you're taking the original points and you're multiplying by the scale factor. So our points for B prime are negative 12, 16. For point C, our dilated point C prime will be 5 times the scale factor and 7 times the scale factor. Scale factor is 4. So C prime coordinates are 20 and 28. For number 8, the triangle ABC has coordinates A, 3, the coordinates are 3, 2, B is 12, 3, and C is 9, 12. Draw and label triangle ABC and the coordinate plane. Okay, that's great. It's been done for us. The triangle is dilated from the origin by a scale factor of 1/3. So would you expect that triangle to expand or to contract? Since the scale factor is less than 1, you would expect it to contract and be pulled closer to the origin. Identify the coordinates of the dilated triangle and then draw and label the triangle on the coordinate plane. Alright, so let's go ahead and get started. We have point A, which is 3, 2. And what you want to do, if you're going to dilate with a scale factor of 1/3, is you're going to take each coordinate and you're going to multiply it by 1/3 to find A prime. 3 times 1/3 is 1. 2 times 1/3 is 2/3. So A prime is 1 2/3. So we go over 1 and up 2/3 of the way and label that A prime. For B, the coordinates of B are 12, 3. To find the dilated coordinate for B prime, we take the original point and multiply it by 3, the original coordinate and multiply by 1/3. 12 times 1/3 is 4, 3 times 1/3 is 1. So B prime has coordinates 4, 1. So we go over 4 and up 1, and I guess I'll label that in a different color, and we'll call that B prime. So we have A prime down here and B prime over here. Next, C. The coordinates for C are 9, 12. Multiply both of those by 1/3, and that will give you C prime coordinates. So 9 times 1/3 is 3, 12 times 1/3 is 4, and our coordinates are 3, 4. Over 3, up 4 to get C prime. Then go ahead and connect your segments to make your triangle. And this is what I was wanting to show you, is that remember that segments dilate to parallel segments. This segment dilates to a parallel segment, and this segment dilates to a parallel segment. So these are similar figures. Remember also that angles dilate to congruent angles. Let's summarize what we've learned in this lesson. To find the coordinates of a dilated point or figure from the origin, given the original points and the scale factor r, multiply both the x-coordinate and the y-coordinate by the scale factor r. For example, if point A has the coordinates b, c, then A prime will equal b times r and c times r. If you're not dilating from the origin, then you would use the definition of dilation. The length of the dilated segment is equal to the scale factor times the length of the original segment, and you would use a ruler. Remember, what we've learned in this lesson applies to dilations from the origin, given the original point and the scale factor.